So the first field that we're going to discuss today is gravitational fields, and you can read about it on page 319 to 321 and 328 to 334 of your textbook. So a gravitational field surrounds objects with mass. Okay, so they occupy the space around an object with a large mass. So, for example, would be here on Earth, we have gravity. And that keeps objects at the surface. Okay, so anytime you have a gravitational field, or any field, you need a source. So that's going to be an object with mass. We also need to look at direction of the field. So in what direction is that field working on the test body? And so in this case, gravitational fields are always pulling the test body towards the center of the source. Okay, and therefore they are only attractive. So they are only pulling you towards the source. So when we talk about fields, we also have to think about vector diagrams because a field is a vector. And what a vector diagram does is it shows the magnitude and direction of your field lines. So first we have to draw our source, which would be any object with a great mass, so like a planet or the sun or a star. And we're going to draw our lines, or the field lines, going towards the center of the object. Okay, and the size of the arrows could depict the magnitude. So bigger arrows, larger magnitude, smaller arrows, lower or less magnitude. Test bodies are objects with mass. Okay, and the units we use to measure our field strength are what we call newtons. Whoops. Per kilogram. So N per kg. Okay. In order to figure out the gravitational field strength, we need to know the mass of the source and we need to know how far we are away from the center of the source. So if you turn in your work booklet to C1, you'll find this page here, and we're going to go through our first formula. So you're also going to need your data booklet, and you're going to turn to page 2 of the data booklet. And you're on C1 of your work booklet. So the first formula we're going to take a look at is gravitational field strength. So if you take a look down towards the bottom of the page, you'll see this formula. Little g is equal to g times m divided by r squared. So little g, again, they tell you what all the variables stand for. So little g is your gravitational field strength. And that's measured in newtons per kilogram. Capital G is the gravitational constant. So this is a value that is calculated, and capital G is always equal to 6.67 times 10 to the negative 11, and the units are a newton times a meter squared divided by a kilogram squared. M stands for mass of the source, and that's going to be in kilograms. And then R, sometimes we think of it as being a radius, but it's really just the distance from the center of the source. And that's going to be in meters. Okay, so physics is a whole bunch of word problems. So in order to do word problems, you just need to write down what you know. and then figure out what equation you need to use, and then solve for your answer. Okay, so let's take a look at example number 1. So they want to know what is the field strength of the sun at the Earth's position, and the distance from the center of the sun to the Earth is 1.496 times 10 to the 11 meters. So first thing we need to do is write down what they're giving us. So they are telling us here that the distance from the center of the sun to the Earth is 1.496 times 10 to the 11 meters. So that's going to be our R value. Now, the source is the sun. So we need to know the mass of the sun. So because they didn't give us a mass, that tells us we have to find it somewhere, and that would be, again, page 2 of your data booklet. If you take a look at the very bottom of that page, you will see the mass of the sun. And it turns out that that is 1.99 times 10 to the 30 kilograms. Okay, so then we have to ask ourselves, what do they want us to solve for? And that is the field strength of the sun. So that's our question mark. And then because this is gravitational field strength, we know that capital G is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. So now that we've written down what we know, we can now write down the formula that we're going to use. Little g is g times m over r squared. So when you're doing a short answer, always make sure you're showing your work. So I need the original, at least the original equation that you were starting with in the problem. So now let's just fill in our values. So using your calculator, you're going to use that second function comma key so you get the exponent. So it should look like this when you plug it into your calculator, 6.67. Use that second function EE key and then just write in the exponent negative 11. We're going to multiply that by the mass, 1.99. Again, use that EE key, and that's going to be to the exponent 30. Plug that into your calculator, hit enter, and then you're going to divide by the radius or the distance squared. So 1.496 e to the 11, and then you're going to square it. Because we use the e key, we don't have to worry about using those brackets. So now when you get your answer and you round it, and we're always going to be rounding to 3 digits, our G, well here, actually let's write down what we get without rounding. So let's plug it into our calculator. 6.67, second function, comma, negative 11, times 1.99, second function, comma, 30, hit enter. Divide by 1.496, second function, comma, to the 11, and then we're going to square it. What do we get? 0.00599308, and it keeps going. And the units would be newtons per kilogram. So always make sure you write that in your answer, especially your final answer. And then what we're going to do, we're always going to round for us to 3 digits. So that means I need to round this to these 3 digits here. So now that's going to become 0.00593 newtons per kilogram. And then just know that we can always write this in scientific notation. So that would now become 5.93 times 10 to the negative 3. And that's going to be a Newton per kilogram. And that would be your final answer. Okay, let's do one more example together. So calculate the value of the gravitational field strength at the Earth's surface. So again, now they're not giving us any information, so that tells us we need to go back to our data booklet and see if we can find it. And you should be able to find the mass and the distance from the center of the Earth to the surface, or the radius. So if you take a look on page 2, you will see that the distance from the center of the Earth to the surface, or the radius, is 6.37 times 10 to the 6 meters. The mass of the Earth is 5.98 times 10 to the 24 kilograms. And capital G is always a constant, 6.67 times 10 to the negative 11 Newton meter squares per kilogram squared, and they want us to solve for gravitational field strength, or that little g. So again, here we go. G, always write down your original equation. Plug in your values, so 6.67 e to the negative 11 times 5.98 e to the 24, all divided by 6.37 e to the 6, and we're going to square it. So if we plug that into our calculator again, hit enter, divide by 6.37 second function, comma 6, and we're going to square that. We are going to get 9.8298, and it keeps going on. Again, the units are newtons per kilogram, and therefore we're now going to round that to 3 digits. So again, we're looking for these 3 digits here. So our answer will become 9.8. That 2 is going to round up to a 3, and I'm always going to put in the units for the final answer. Okay, so there's just one more equation for gravitational field strength, and I'll give you the assignment that you need to do, or the work that you should do to practice, and that would be the force due to the gravitational field, the force due to the gravitational field. So that equation is also found on page 2, and it looks something like this. So F equals m times g, and you might remember this from grade 10 science, except we were looking at gravitational potential energy, which is kind of the same thing. Okay, so F with that little arrow over top tells us it's a vector, so this is the gravitational force acting on our test body, and the unit for force is newtons. The mass now is going to be the mass of the test body, because we want to know how much force is acting on the object being affected by the field. And again, that unit will have to be in kilograms. And then G is that gravitational field strength at whatever location you are from the center of the Earth. And that's going to be newtons per kilogram is the unit. Okay, so let's take a look at this question here. So a person with a heavy backpack has a mass of 100 kilograms and can be considered a test body for the gravitational field. Use the value from example 2 to predict the force of gravity, Earth would exert on this person. So now we're not interested in the mass of the source, we need to know the mass of the test body. So that's going to be 100 kilograms. We also know that we're at the surface of the Earth, and they tell us to use the value of G that we calculated from example number 2. So we'll use our rounded number, 9.83 newtons per kilogram. And what they want us to solve for is what is the gravitational force on that person. So what force is holding that person to the Earth's surface. So if we look at our equation, we're going to use F is equal to m times g, and we're simply going to plug in our two numbers, 100 kilograms times 9.3 newtons per kilogram, and that's going to give us 983 newtons. And that would be your final answer. So the force due to gravity, or the gravitational force, is 983 newtons. Okay, so there is this practice problem here that by all means, if you'd like to do, please do. It's in your textbook on page 334. But if you're looking just to practice the stuff that we did just now, if you turn to C2 and C3, you will see a whole bunch of problems on gravitational field strength and force problems. So you can give those a try. There is an answer key posted in the lesson under content. And then the last thing I'd like you to do is to try the plotting the gravitational field strength of Venus, which starts on C5. And that's just going to show the relationship between Venus, mass and field strength, and distance and field strength, which is on C6. Okay, so complete workbook, page C 2 to 3, and page C 5 to 6. And the answer keys are posted on under the content as well.